This video shows you how to use SPSS Modeler to build a machine learning model for publicly available data about metabolic diseases to determine if someone has chronic kidney disease. Start in the Resource Hub. There you'll find the dataset used in this video. It's from the University of California, Irvine, and is the result of an extensive study based on hospital admissions over a period of time. There are 3 important factors that help predict chronic kidney disease, which are available as part of this analysis: the age of the test subject, the serum creatinine test results, and diabetes test results. And the class value indicates if the patient has been previously diagnosed for kidney disease. Add this dataset to a project so you can use it later. Now view the project. And on the Assets tab, you'll see the dataset. Now you're ready to add a new modeler flow to the project. Just provide a name, select the runtime environment, and create the flow. This opens up the canvas that you will use to create a flow. In the palette, in the Import section, drag the Data Asset node onto the canvas. Double-click the node to change the dataset. In the Data Asset section, select the Chronic Kidney Disease CSV file. Then save the changes. After you load the data, you must transform the data. You will be creating a simple flow by dragging operations and estimators onto the canvas and connecting them to the data source. In the Field Operations section, drag the partition node onto the canvas. Next, connect the data source to the partition node. The default partition divides half of the data for training and the other half for testing. Back on the palette, drag the Type node to the canvas. Connect the partition node to the Type node. This node will set the data type. You'll see that in a moment. Then double-click the Type node to see the settings. This is a list of the fields in the data file. Locate and select the class field and change the role to target. Remember that the class value indicates if the patient has been previously diagnosed for kidney disease. And then save all the changes to the node. Back on the palette, in the Modeling section, drag the C5 node to the canvas. Connect the Type node to the Classification node. By default, the C5 algorithm builds a decision tree. A C5 model works by splitting the sample based on the field that provides the maximum information gain. Each subsample, defined by the first split, is then split again, usually based on a different field. And the process repeats until the subsamples cannot be split any further. Finally, the lowest level splits are re-examined, and those that do not contribute significantly to the value of the model are removed. Double-click the class node to use custom field roles. For the target, select the class field, which indicates if the patient has been previously diagnosed with kidney disease. Then add input columns, namely age, SC for serum creatinine, and DM for diabetes. And then save all of the changes to the node. Now you're ready to run the model. When it's complete, you'll see a new model nugget, which is the trained model. Click the model nugget to see the option to view the model. Review the provided model information. The feature importance shows that serum creatinine is easily the most significant factor, with diabetes being the next most significant factor, and age being the least significant factor. The top decision rules displays a table containing a series of rules that were used to assign individual records to child nodes based on the values of different input fields. The tree diagram displays the same model in the form of a tree, with a node at each decision point. The top node provides a summary for all the records in the dataset. Just over 40% of the cases in the dataset are classified as not diagnosed with kidney disease. The tree can provide additional clues as to what factors might be responsible. Notice the two branches stemming from the top node, which indicates a split by serum creatinine. This branch shows records where the serum creatinine is greater than 1.25. In this case, 100% of those patients have a positive kidney disease diagnosis. This branch shows records where the serum creatinine is less than or equal to 1.25. 75% of those patients don't have a positive kidney disease diagnosis, but still almost 25% with lower serum creatinine were diagnosed with kidney disease. This node is split by diabetes. This branch shows patients with low serum creatinine and diagnosed diabetes. 100% of these patients were also diagnosed with kidney disease. This branch shows that for patients with low serum creatinine and no diabetes, 82% were not diagnosed with kidney disease, but 18% of them are still diagnosed with kidney disease. This node is split by the last significant factor, age. This branch shows that 100% of young patients with low serum creatinine and no diabetes were at risk of getting kidney disease. This branch shows that only 12% of patients over 14 years old with low serum creatinine and no diabetes were at risk of getting kidney disease. Now go back to the canvas. From the palette, in the Output section, drag the Analysis node to the canvas. This node lets you view the model and check its accuracy. Connect the Model node to the Analysis node. To see the model accuracy, right-click the Analysis node and run it. In the slide-out panel, click the Analysis Output. The analysis shows that the model correctly predicted a kidney disease diagnosis almost 95% of the time. You can save this flow as a streams file. This downloads an STR file to your local machine with the scoring branch pre-configured for deployment. The scoring branch is the path through the stream which will be executed when the deployment job is run. Next, from the Analysis node, you can save this as a machine learning model. Just provide a name and save the model. Lastly, from the Output section, drag the table node onto the canvas and connect it to the model nugget. This node lets you preview the dataset and the predictions. The $C class column contains the prediction of kidney disease, and the $CC class column indicates the confidence score for that prediction. If you return to the project, you'll find the modeler flow on the Assets tab. You'll also find the machine learning model that's saved from the Analysis node. When you view the model, you'll see a summary and the input schema. And from here, you can promote the model to a deployment space. Select a deployment space from the list, check the option to go to the model in the space, and promote the model. Now you're ready to deploy the model. In this case, select Online. Just provide a name and click Create. When the deployment is ready, View the details. On the Test tab, you can test the deployment either by directly entering input data or by pasting JSON-formatted input data. In the results, look for the two fields, C class and CC class, described previously. Find more videos in the documentation.